So I have a tendency to wander around, so I guess I need to stay here.
Want to take the mic off the stand?
No, that's fine. Yeah, that's fine. So looking at the theme of the conference, which is sustainable and resilient communities. So the question is, how do you go about building such kind of communities? So when I look at, I took this text from the website. It has number of terms there: high performance building, human-centered urban design, cyber-physical interactive environments, smart grid, power systems. So number of different aspects. Many of them, there are infrastructure type systems, power systems, smart grid. Then there is also human-centered aspect, urban design. So there are a lot of different aspects to be addressed when you want to build up such resilient and sustainable communities. So this concept of building communities, smart communities, connected communities, it sort of started in about the past 3 or 4 years when it sort of started picking up a lot of steam. And so back in my previous life at NSF, there was a lot of activity going around at that time. So I was fortunate to be part of some of the planning that went around in building programs around it. So I'll share some of my thoughts and perspectives on what I learned through. Mm-hmm. So we had a call for proposal at NSF for smart and connected communities, and then see a lot of proposals in response to that. And then we tried to do, try to analyze it and see what were the dominant themes, and you can see basically they are all over the place. Energy, energy appears quite a bit. Then the visualization techniques, there's a lot of crowd-sensed data, social media data, edge devices, transit systems, so it's all over the place. So the question is, that how do you sort of go about looking at designing such, building a research agenda for such a wide-ranging set of topics? So one of the things you go around is do some visioning exercises and try to sort of portray what's going to be the future. So just some historical perspectives, or Jetson. So in the 60s, this was a television show where they talked about this communities where they with families on aerial vehicles, and so that was sort of interesting to see. Then there was Star Wars after that. So just to be clear, I'm not that old. I just saw the reruns. So, so Popular Science magazine in '88 talked about smart house as a model, and that catalyzed a lot of research around that. Right around 2009, at NSF, we had a vision of what future smart communities should look like. It had many elements of smart infrastructure, power grids, healthcare systems with devices which are embedded inside the body and are communicating with the outside world. So those were kind of visioning exercises which says, okay, what do we want to see in the future? And you sort of lay out this broad vision, and then you try to develop technologies around that. And that sort of jumpstarts a lot of technology development. That's what we saw. You see that things are progressing at a very rapid pace. If you look at the devices that are there around us, they are predicting some predictions of 50 billion, 100 billion. Doesn't matter what the number it's going to outnumber humans by a lot. So we need to sort of look at those and see how we can leverage all of that. Mm-hmm. There is a lot of activity around self-driving cars, so that's generating a lot of new technologies to be developed. In the healthcare systems, biomaterials, there's a long list that you can see of technologies being developed and being, are they ready to use? Okay. But when you sort of pick these technologies and go out in the real world and try to say, okay, I want to now apply this. So one instance I'm just putting up over here is, so I wanted to address the problem of last mile delivery, which is delivery of to small businesses in Manhattan. Okay. So that's actually a big problem. A lot of the traffic congestion is actually caused because of this, and there are predictions of how much energy and gas basically goes into just this particular activity. A lot of solutions being developed. So there are the drones that could address this problem. A lot of activity around that. Are they going to work for Manhattan? We don't know. A lot of logistic challenges to be addressed there. There's another project that NSF funded at MIT Media Labs, which is basically looking at these self-driving cars, vehicles which are convertible vehicles. You can use them as delivery vehicles. But again, a lot of challenges. Where do you drive them if they're self-driving? Well, they said in Boston they have bike lanes everywhere. You can do that, but often there are cars parked there. A lot of things that need to be addressed in them. But one technology we know that works, right? So some of the simple technologies, they work very efficient. So one has to sort of reach a place where, what's going to work. So that's the important thing over here, that we are developing technologies, but we need to see what works. Not only we want to see what works in the idealized work, but we want to see also that if let's say there are extreme events, disasters or other happen, are they still going to work? Okay. So you want them to be resilient. So that's where the resiliency concept comes from. Okay. So there are, if you've seen the movie Martian, so that's an excellent example of where, you have fixed set of technologies available, fixed set of resources, and you want to optimize the use of all of them in order to optimize your quality of living. And this is a case where there is very extreme environment where you have to deal with. And the trade-offs that you have to make, it's not just there are economical trade-offs, but it's existential trade-offs as well. So those are the kind of things, so The Martian is a movie that sort of tells you exactly the type of things that we need to do in our communities. We have technology that we available to us, a lot of economic conditions, environmental conditions, political, and you have to sort of do this multi-objective optimization to see how do we make these work best for us. So that's the kind of problems that we want to look at, is how do you get to a research agenda which enables us to do that. So so that's sort of the theme of my presentation, is that we have these technologies, infrastructure that are available to us, but really what you need to do is to engage with multiple stakeholders with multiple disciplines over here. So you need to engage industry. You need to look at, for example, are the humans going to accept it? Are the people, human interaction, human-centered is a very important part of it. Then you also need to engage with communities, the city planners and the community planners, to see, is this going to work for them? Are they going to be able to integrate all of these into their existing infrastructure or not? So you have to sort of look at all of these aspects in there. So at NSF, there were a number of programs that were designed right to sort of address many of these issues. So I'm going to walk through a sequence of them to sort of give a flavor of them. So the first one was basically looking at infrastructure systems. So how do you look at infrastructure systems and guide their development towards things which are useful to us in building sustainable and resilient communities. So if you look at infrastructure system, the things that come to mind are smart buildings, smart transportation. They're smart in front of everything, right? So if you go back, rewind 10 years, all of these 10 or maybe 15 years, if you just take this, the buildings, the transportation, the power grid, that part of it, they were all purely physical systems. I mean, there's a lot of mathematical analysis and all of that you need to use in order to make it work, but they were purely treated as physical systems that you operated. Okay. Then you kind of added the smarts to this, which is essentially the cyber element of it. So you added all the cyber infrastructure, and so you can integrate some more intelligent decision making and all of this to them. And that was the cyber part of this. So that sort of gave rise to the area of cyber-physical system, that most of the infrastructure systems that you have now, they are a combination of cyber and physical together. And these are cyber and the physical, which are tightly integrated and interacting with each other. So that's the whole concept behind cyber-physical systems. So typically the way if you sort of see this particular, any one of these smart systems, the story basically in all of these smart systems is that you are basically have a component which is sensing, observing the physical system, okay? And then based upon those observations and sensors, you are analyzing that information that is being collected, okay? And then that analysis basically leads you to some control actions or some actuations that you then do on the physical system, and then the cycle repeats. So in some cases, this is a very tight-knit cycle. So if you're basically looking at a self-driving car, then the cycle operates in the order of milliseconds, where you're continuously observing where the car is going, and then you're doing some control and steering actions. In other cases, it might be of the order of days, or it could be a matter of hours. So if you're observing transportation traffic, then you're looking at the cycle operating in the matter of, it's not milliseconds, but the cycle is of the grain of maybe an hour or something like that. So the time scale varies, but that's the basic principle that you see in there. So for instance, there's an example where you can take a bridge, which is your physical infrastructure, add sensors to add monitoring activity and devices to that. And then you can, based upon that, based on these observations, you can either recommend repairs that need to be done, you can proactively take actions on that. So basically you made it a smart infrastructure which can predict its health, recommend actions need to be taken, and in that process prolong its life. We see so many examples of smart health where you've got devices that are attached, wearable devices, which are collecting information on a real-time basis, analyzing it, going back to your medical electronic health records, correlating there, and then providing you feedback on what needs to be done. So that's an example of how, for example, cyber-physical systems sort of play in this. So, and there are, a number of different areas. If you look at transportation, energy automation, healthcare, everywhere you will find cyber-physical systems. So they involve, pervasive computation, networking at different scales. So there are a number of, interesting issues, research issues that need to be addressed. But part of the thing that we also, that was emphasized in this particular program was industry involvement. Because all of the infrastructure, I can develop all the theories that I want to do. Again, are they going to work in practice? And so we wanted, the NSF basically in this program, they wanted a lot of deployment as well as evaluation to take place. So industry involvement was perceived as very, very critical. And here is kind of the flower diagram, which CPS stands for Cyber Physical Systems. So at the petals, you essentially have all of the application domains where you can pick your favorite application cyber physical systems. But there's a lot of interesting technology that needs to be developed around control, verification, safety, sensing, and all of that. And that's core technology that develop, which then applies to any kind of domain that you want to work in. So if I'm developing, let's say, a sensor technology and it's motivated by medical domain, but that sensing technology may then also be applicable many other places. So this is a program that has been in existence since 2009. The term is about, cyber physical system is about 10 years old, and there was, a lot of ideas that were kicked around, and eventually it was launched in 2009. It's a multi-agency program. It has 6 agencies involved: Department of Transportation, DOT, NASA, DHS, NIH, USDA. So a lot of interest, cross-disciplinary interest in this. And the community is building each year on that. This is kind of an analysis of portfolio. You can see number of different domains, from transportation to unmanned systems, energy, smart buildings, manufacturing, all of them represented in the proposals that we received. Okay, so that's essentially an exercise. That's a lot of, this particular program has catalyzed and allowed us to organize a lot of research around development of infrastructure systems that are there in our communities. Okay? And so the next thing we want to sort of walk through is, how does human interaction play an important role? So if you look at all of these infrastructure systems, typically, development of these infrastructure system and also the deployment in the communities is all siloed. So you have electricity department, which manages your electrical infrastructure, the water, and from the city and the community's viewpoint, doing this thing in silos, there's a lot of redundancies. So they have a lot of redundancies, they have a lot of additional cost. In an idealized world, that they would leverage the infrastructure and merge them. And that studies have shown that can result in a significant cost saving. Okay? But from the perspective that I'm going to describe is that these infrastructure, even though in our communities, they don't exist in isolation. They are really interdependent on each other. So you will never see a transportation system exist all by itself. There's a lot of interdependencies between them. So for example, and the thing is that the failures from one particular infrastructure can propagate onto the other. So for example, there could be what you call a direct dependency, where there is a hazard event, and then the emergency repairs required to address that particular repair. Okay, that's needed. So you need the emergency responders infrastructure in order to do the repairs. But perhaps the repairs cannot be, because of the transportation infrastructure is down, the emergency crew cannot get to it. So you see this kind of a dependency between them. Okay? So if you sort of remember the event that happened in Atlanta, where there was sort of hazard, disastrous event, which was half an inch of snow, which in Syracuse would be nothing. But again, people there didn't know how to react. So it's all about how humans respond. So here, everybody would have not paid any attention to that, but there everybody basically panicked, and at around 3 o'clock, everybody decided to leave. And because everybody decided to leave, there was congestion on the roads. And as a result of which the first responders and also the city officials, they got stuck in the traffic, and they could not get to their duties in order to clear the roads and all. So there was this propagation of failure from one infrastructure to the other, and in particular the air flight crew and all, they could not get to the airports, and hence the flights were delayed, and the delays were propagated throughout the country. In fact, went all the way up to in California and other places. So those are the examples, where these infrastructure, they are dependent on each other for functioning. And what you want to do is to design them in such a manner that this impact of these failures of one is the propagation gets mitigated. I mean, you clearly don't want to design them as independent. You want to design them as interdependent, because they are naturally interdependent. But you want to design them in such a manner that the failure impact is mitigated there. So this was a program which was started about a couple of years ago, CRISP, Critical Resilient Interdependent Systems. So here in the infrastructure system, so the interesting things about this is that you want to study the interdependencies of the infrastructure system. You want to conduct the real evaluation. So human element, we thought, was a very, very important aspect in that. Okay, because infrastructure system, that they are used by people, they are used by the city planners. So involving them is a very, very important thing. So we required that every proposing team have one computer scientist, one engineer, and one social scientist in there. So very interesting proposals. So the first year around, when you received the proposals, it was kind of a very haphazard mix of, let's get 3 people together and write a proposal, and it was kind of marking the checklist saying, yes, we have all these 3 people represented. But then the feedback went back, and the next year onwards, you really saw proposals interesting integration where the research in humanities, for example, in social sciences, economics, others, really informed how to develop the technology. So that's exactly the type of thing we wanted to see, is how does these three pieces sort of inform each other in order to advance the research. In one project, we may not be able to see deep scientific contributions in each one of these three fields, but you want to at least have deep contributions in one or two, but have the others inform it. Okay, so that's the important thing. And so this is a very, NSF-wide initiative, multidisciplinary initiative, and it's yielding pretty good results in terms of studying the design of infrastructure systems. So again, the key goal here were to look at interdependent infrastructure systems, study their operations, design them to be resilient to either intentional or natural disasters. So I'm not going to go through the list over here. So again, so that was one program where we taught the human element, and that was very important in order to integrate them. So the final thing is to look at how do you make these technologies work in the community. So let's say that I've designed my infrastructure systems, my cyber-physical system, I've got the right kind of sensors in place, right kind of technologies in place to provide feedback and control the system. I've also addressed the interdependencies that I need. And now I want to make sure that now I'm ready to deploy these technologies, make them work in a community. So that's where you basically look at the concept of smart and connected communities came across. So if you look at smart and connected communities, so what does it mean for a community to be smart and connected, or what does research in this particular domain mean? So essentially, it's all about better decision making. So you want to provide technologies which enable people to make better decisions, smart decisions. So the smart decision could be either at the individual level. So for instance, today I want to know I want to go from here to Binghamton, which route should I take? So that's the, so I need to have technologies in place, perhaps the apps and all that you have. Those are technologies which help me make a right kind of decision. Or it could be a particular class of citizens. So let's say bicyclists, what kind of technologies are available to enable them to improve their quality of riding a bicycle through the city. Okay. So it could be a particular class of people, or are the technologies enabling them to make better decisions? Or it could be first responders, your city planners, what kind of technologies are available to them in order to have them make better decisions. So it's all about making smart and better decisions, and it's at different levels where you are trying to go. And eventually, all of these should converge in order to improve quality of living. So that's the bottom line, that if it is making these technologies work in a community, then they should be impacting our quality of life. If you cannot quantify that, then we don't sort of consider that as smart and connected communities research. So again, if you look at smart and connected communities, what are they doing? If you go around the country, we talked to a lot of city planners, invited them to several workshops and said, okay, tell us what are you doing? What are the things that sort of drive your decision making? So essentially, they are looking at convenience, savings, sustainability, safety. Those are the typical kind of things that they want in order to improve their cities. So again, a lot of depends upon where they are right now. So some cities, they are at different stages. So some cities are at very, very early stage, and they are just looking at infrastructure deployment. So saying, okay, I want to make Wi-Fi available to everyone. Okay, so that's shown to improve quality of living. It's definitely going to improve quality of living. In Chattanooga, for instance, it said that that brought in a number of different jobs, certain number of jobs in there. Other cities are just looking at traffic lights, city lights, and trying to sort of making them smart. And that's also enabling, so that's starting at a very basic level of infrastructure development. Others are more advanced. They say, okay, we have done all of that, gone past it. What else can we do? Okay. So for example, in city of Chicago, they have these trash cans, big belly trash cans, which already have some instrumentation in them, which these trash compactors, they can signal the truck saying, come pick me up when they are full. But what they said, okay, we have these on every street level, on every street we have these trash cans. What can we do with this infrastructure? So they put in a lot of air quality sensors in there. Okay, so now you have got street level air quality information available. A number of different apps were designed in terms of, okay, today if I need to take a walk, which way should I go? And it's also giving you levels, information at certain, what's the pollution level at 6 feet versus 3 feet. So if I'm going with a stroller, which particular path should I take? So, they are sort of doing even, again, this is technology. It's just trying to make technology work. It's not rocket science. I mean, these sensors are available. You just need to make it work. So there are other places they are installing these intelligent street lights, which have all sorts of things in them. Again, these things, just trying to make things work over here. So this was an interesting chart which was prepared by a company which rates the cities based upon what kind of, where they are. So there are cities which are basically doing things on an ad hoc basis, on a one-time basis, saying, okay, yeah, I can do that and be done with that. But there are others which are much more opportunistic, saying, okay, I need to make this investment. How do I best make that? So they are involving some stakeholders with cities, stakeholder, either the industry folks or others, and trying to leverage their collective expertise in order to make investments. So they are at a different level than the first group. Then the third group is where they are basically saying, okay, we have learned lessons from them. Let's repeat them and apply them at every time we are trying to make any kind of infrastructure investment. And then there are others which are even doing much more managed. They are much more institutionalized. And then the optimized ones are the ones which are, so in their ranking, there was no city that reached that particular scale. So that's, which is doing much more idealized investments in there. But again, so in order to sort of look at this particular research agenda, what we looked at and said, okay, what constitutes smart cities research, and what should be our focus and agenda? So the status quo which we find was that there was just too many projects which were short term. They basically said, okay, here is a problem. They're basically trying to address them. These are solutions which are just stitched together and made to work for a particular city. So so we really wanted to get away from these kind of small islands of successes and make the experiments more repeatable. So that's essentially constitutes research, is where you can get some lessons learned out of this, saying, how did I put all these pieces together, make it work in a city, and then go replicate it at another city. Okay. And the other thing was that, we wanted the researchers to always, they claimed social improvement, and they said, okay, this is going to make it better. But really what you wanted to do is to quantify how much better. If it is improving quality of life, what does that mean? Or if it's making things better for bicyclists, quantify it. Is it reduced time? If so, how much? If it is less number of accidents, tell us how much. So if you force people to think in that direction, we found that, many interesting things, they sort of start to think deeper and try to sort of see, okay, then they really start to involve the different stakeholders that they really need to in order to quantify these improvements. So again, the research plan there is, we are looking at long term. We want to look at longer term, 10 to 15 year time horizon. Okay, but we really want to also see some off ramps where you are basically looking at technology pieces that are coming either in a 2-year or a 5-year time frame, so that you can actually see the impacts of that. So in doing all of this, the type of things that we are trying to promote there are really these partnerships between academia, industry, and city. So if you look at academia, So we like to work on research problems in academia, and very often, we want to work in idealized environments. We try to make up problems and try to solve them. Okay. But on the other hand, if you talk to academics, they basically say, we want to work on real problems, but they are not available to us, or the infrastructure or the system is not there to work on those. From the industry viewpoint, what the industry is looking short term. They want to have very, return on investment right away. They basically want to partner in all of these things, and their real reason to partner is because they want their technology to become part of the solution. If their products become part of the solution, then they can sell them. So there is motivation on their part to partner them. Then if you look at cities, essentially talking to the cities, no city manager will come and say, I have got a lot of money here and let's try out a few solutions and see which one works. They basically want solutions which are there, which they know which will work, and then they will buy them. Okay. So really what you want is partnership between them. Then you got, cities are if you look at experimentation facilities, for example, academics, they want to say, okay, we are going to do research, but we want places where we want to deploy them. Okay. So if let's say they are working on multiple infrastructure, transportation infrastructure, they're working on power infrastructure. It's very difficult for them to even looking at a single infrastructure alone, if they want to, let's say, do some studies on traffic management. Very few places where you can actually deploy them and see the impact. You can do it in simulations, but in real practice, very few places. Similarly for the power. Okay. And again, there are places where you can do them, but these are places, these test beds are all separated out. Now let's say that I want to study the interdependence between them. There is no place where you have these two test beds together. But cities are one place where you have all of them. These are naturally deployed. You have all of the transportation, power, any first responder, all of them are there in the city. So you need to have effective partnership with the cities so that they can allow you to deploy these in a controlled fashion so that you can see the impact of that. So that's where you see a lot of benefit there. The cities have a lot to offer, because they are the owners of these infrastructures in some sense, and they can make the facilities available. And industries are going to come there because if they form part of the team and their solution and their product becomes effective, so they're selling smart meters or whatever, and they seem to work in one place, then everybody will buy them. The street lights which I showed, there's a company in San Francisco which manufactures them, and they've been shown to be effective. Now wherever they want to do that, that's the product that's being used there. So these kinds of partnerships is the one that promoting at NSF quite a bit and throwing a lot of money at these kinds of partnerships. And it's kind of a win-win situation for each one of them. Mm-hmm. So there are, several examples of this. So for example, there is a lot of systematic investment being done in Lower Manhattan, where they have deployed quite a bit of these sensors. Again, these are sensors on the trash cans as well as in the other street lights and all that they have. So this is a systematic investment that they did in deploying this infrastructure. Now it is being leveraged for many different projects. So it's not just being used for air quality monitoring, it's also being used by the city officials, the first responders, the police department, and so many other projects are sort of using this particular deployed infrastructure, and is kind of a good example of a partnership between academics, city, and industry in there. There's another one in Columbus, Ohio, which we initially funded on last mile transportation there, where they're using automated vehicles in order to transport people back and forth from bus stations and the train stations. And based upon this deployment, they just won the $50 million DOT competition that just concluded. And so DOD is investing $50 million. The city of Columbus is putting in about $100 million, and so they're making this huge smart city effort in there and on the deployments. So again, there are several other examples that I have where these kind of partnerships have been very, very effective. In Kansas City, for example, there is a section that they are developing. Google already has the fiber in there. Sprint is providing Cisco is providing all the networking hub. There is universities which are participating in the research. And the city has opened up the infrastructure and say, come do whatever you want in this particular section, and we'll learn out of it. And so that's the kind of partnership that needs to be developed, and you basically get a lot of mileage out of such partnerships. Okay. So again, some guiding principles that we just mentioned earlier, that need to look at the problem for multiple dimensions, multiple application domains. Again, we wanted to not look at problems. So earlier, when the term was being used, smart cities, and we had some workshops, there were problems of Boston, Chicago, Atlanta. Those were the ones being addressed. But there is a whole lot of rural America that wasn't being looked at. So we changed from smart cities to smart and connected communities, because everybody is facing different types of challenges and problems that we want to bring to the forefront. So looking at different scales and constraints in there. Again, scalability of solutions. We want it to be repeatable solutions. We want the quantification of impacts. You really need to quantify exactly how much better you are doing, improving the quality of life. It's not just better. What's the percentage that you are there? So overall, I just want to conclude by saying that that in order to develop sustainable, resilient communities, it's a multidisciplinary, multi-stakeholder research agenda that one needs to look at. Technologies are being developed at very, very rapid pace. So we really need to look at what's the effectiveness of these technologies and provide feedback to them in what direction needs to go. And the feedback has to come from this partnership that we have with industry, with cities, looking at human-centered design. Are people going to be using this technology? Are they going to be receiving, looking at all the Internet of Things, but privacy is a big concern. And that's a human concern, human-centered concern. So unless and until we address that and provide feedback to the developers of technology, saying incorporate that in the technologies you are developing, things are not going to move as planned. So thanks.
Thanks very much for you don't get off the stage yet.
I don't.
So we've got a couple of minutes for questions. We have 2 microphones on the floor. I'm going to invite folks who want to ask a question to come up to one of the mics. And in the meantime, I'll just say that was a great way to start us off. As you think about our program for tomorrow, you see that there are 3 tracks in the program. There's 4 sessions in each track. There's a total of 12 sessions. There's at least 7 of the sessions that touch cyber-physical systems. The entire energy track, in the design track A3, dynamic and adaptive building systems for environmental control. And then in the futures track, C3 and C2. So in particular, the vision of academic industry city collaboration. Tomorrow in session C2, the city of Syracuse will present its efforts on innovation in applying cyber-physical systems. I don't know that any of the members of the Syracuse I team are here, but they'll be here tomorrow. And this, you came to the right place. So
yeah, so that's exactly the type of things you will want to, yeah, please.
So it was interesting that you brought up privacy at the end. I think that there are some European cities that are doing a lot with smart and connected cities and fast internet infrastructure. How much is that privacy impeding the deployment of cyber-physical systems? Because I think in Europe, they don't care about as much. They apparently trust their government to hold the data. And, they file their tax returns online and they vote online, and it's not a problem for them because they don't see that the government they don't have a problem with that. How big of a problem is it here in the U.S.?
It's a substantial problem, and the thing that's going to happen there is they're still waiting for the very first disaster to happen as a result of, and that's just, but the thing there is that within the U.S. they are approaching it very cautiously, and whereas you don't, in other countries we find that they are progressing much more rapidly. So it's not just in privacy. If you look at some of the other in other countries, especially in the South Pacific, Singapore, and many of the and even in many European countries, they are far ahead in deploying smart cities technologies than in U.S. And part of it is again our cautious nature and also our bottom-up approach that we have. In many of these places, they can mandate other places from top down, saying this is the way it's going to be. For example, some of my colleagues there say that in China, for instance, they mandated every taxi has to carry this sensor, and now they have suddenly a big sensor network that they can experiment and evaluate their technologies on, and whereas we don't have any such thing here. And so here we are approaching things very cautiously, and it is hindering our efforts to some extent. We had a very interesting workshop between Europe and US on privacy, and as you're right, they're completely different views of what privacy means, and they are much more trusting, or they have given control away of their data, whereas we haven't.
And if nobody else is asking a question, I'll ask another one. It's interesting to see how connected these systems are. How much of an effort is Homeland Security type of activities playing into this? Are they kind of counterproductive to work together, or is the idea to work with security aspects?
Actually, Homeland Security is very, very supportive of that. In fact, if you're looking at resilient infrastructure systems, DHS is the one that's putting in most of the money funding into it. So they have a number of center of excellence that they have funded in there, and the primary research is in developing these looking at these interdependencies. So they are they want the communities to be resilient. They want to develop best practices for the communities to follow, and they want to follow this particular model that I just talked about community engagement, do research that is, or develop techniques which are relevant and can be implemented in there. So DHS is actually, they are very, very at the forefront of this and supporting it.
Quick question. It seems that maybe there are two ways to look at the growth of these cyber-physical systems. One is more of a top-down approach from the municipal level. One is perhaps more of a bottom-up approach, in which more than one vendor is able to participate in this sort of new type of infrastructure. If that's true, is the major limiting factor at this point to wider adoption more cohesive standards? In many cases, it seems like the technology exists, but it's the coordination effort that we're lacking.
Right, so the technology pieces exist, and multiple vendors want to have that kind of, so from the vendor viewpoint, they basically want to have these standards and to be developed so they can each just focus on the technology that they are developing and they are able to plug it in. But we are not at that stage yet in terms of standardizing. If you look at, if in many other situations, many other application domains, the communication stack and all, everything was standardized, and people could vendors could focus on particular technologies. For cyber-physical system, we are not there yet. There is a cyber-physical systems reference model that is being developed, There is a big push by Industrial Internet Consortium, which is trying to standardize some of those things. So these things are not yet, we are not yet there. But again, the thing there is that at the municipal level and all, they need to at least have a framework defined, saying these are the infrastructure systems, and this is how, if everybody is want to compete for a design of a new parking meter, here is the parameters. Right now, it is all single source contracted out, and so it's done on a one-off basis. So we are not there yet in terms of standardizing.
Thanks very much.
Thank you.